Hi everyone, I wanted to go over Lab 7 introduction, and this one is a little bit different because we won't be using pivot for this lab. So this lab is on forces and torques in equilibrium, and there's a bit of background information. You can watch it, you don't have to. They're just information on torque. That you might get more information listening to somebody else than my lecture videos. It's totally up to you, but it's just there if you want to use it. Okay, so if we want to begin, we want to click this link here. Okay, and it'll take you to PhET, and this is another interactive simulations site. Okay, so you'll want to first go to intro, and it states that in the lab as well. Okay, and you want to kind of play around what's going on, the different features in this lab format. Okay, so here I can have my mass labels here on these guys. I can have forces of objects on. I can have my level point on, which is when these this board here is level. Okay. I can also have a ruler on, so I can measure the amount of meters I place an object, okay, or the distance from the center. Or I could just have marks, but I would go with rulers, that way you know an exact meter here. Okay, so that's a bit about that. As far as looking at the torque, we're going to be having to use this distance here, okay, and we'll be using this button a lot. Okay, so this is releasing these balance beams, you can say, just to hold it up. And when we take that away, we can see what balances, what doesn't. Okay, so if I take 5 kilograms and place it on this side, I can see, oh, does it balance? Not quite. Okay, but if I move it, maybe to 1 meter, it'll balance. Okay, so just kind of play around with this a little bit, this first portion. And this is going to be the first part of the lab. So in the first part of the lab, you want to go to the Balance Lab tab. Whoops, right there. So I'll go to the next tab here. And then I will start doing the lab. Okay, so each of the cases that are listed below are going to have the same exact questions, okay, in this part. So first, you're going to calculate a prediction using this torque equation. Okay, torque equals the radius, or that distance where the object is placed, times force, times sine theta. Sine theta in this case is going to go to 1. Okay, so you don't really need to worry about that. So it would really just be torque is equal to RF. Okay, so for where you place the mass to the left of the pivot and then record the prediction. Okay, so for example, this first one, I'm going to place my 5 kilograms on the right of the pivot at 1 meter. And then I'm going to place 10 kilograms to the left of the pivot. Okay, and then I will show a calculation. I will put in an attachment, so I would say insert, image, in order to show my calculation, okay, of where that 10 kilogram mass will be. Okay, so I'm not just going to go through and find exactly what it is. I want to try to calculate it. Okay, so it said 5 kilograms at 1 meter, and then I'll just put it somewhere, maybe the same one, but then I'll go ahead and do my calculation on a piece of paper or on an iPad or something. That way I can upload it and show, okay, it should be at blah, blah, blah radius or distance from the center for this to be balanced. Okay, so that would be the first part. The second part would actually be to test that prediction. So now I'll go through and I'll say, okay, where do I need to place this for it to be balanced? Okay. And so that's the experimental portion. So this is theoretical, and this would be experimental. Okay. If your prediction is not correct, then you'll provide what distance you were able to balance the board. Okay. And then from there, you're going to actually do a little bit more math. So what you'll have is you'll put your, or calculate the sum of your clockwise torque, then your counterclockwise torque, and then your total torque. Okay. And then again, you'll show your work as an attachment. Okay, so this is all explained in here as well. Okay, and so you'll have 5 cases to do this with. So you'll be moving around the different masses here. So if I have like a 20 kilogram, then I need to balance it. Okay, and so forth. Okay, so there's 5 different cases, like I said. Okay, so I'm going to scroll down through them. All right. So the next part is to find unknown masses. And this is where we have some mystery objects. Okay, so we'll go to the balance tab again. Okay, so that's the same tab. And we can go through here and find our mystery objects. Okay, you're going to do E through H. And I can just put those away. So what you'll do is you'll use the same techniques, but this time you are going to try to figure out what this mass is. Okay, so you'll want to balance it, see what distance it balances. Okay, and then from there, you can calculate the mass of that mystery object. Okay. All right, so there's a data table here that you'll need to set up. You can draw it, you can put it in Excel, whatever works for you. I don't care as long as you have this data table done and showing calculations. So I don't want you to just do it all in Excel and then I don't know how you calculated anything. You need to write that out, okay? And then just draw some kind of conclusion, answering a couple of questions. And that is the end of this lab. So again, if you have any questions with this lab, feel free to contact me.